This is the application code. It is a rugged board I2C EEPROM .c, and this application is to write and read the EEPROM interface via I2C. So as mentioned in the theory, that EEPROM in the rugged board is connected to I2C, and its slave address is going to be 50. So this is the required header files. These are the required header files which we need to include it, and then this is the path that EEPROM present in this is class I2C adapter. In that I2C 0, so this 50 is the address. In that address EEPROM. Okay, so we are accessing the EEPROM. So for that, this is the path we need. This is the file we need. EEPROM file we need. So using this, we will be writing and reading the content. So the main entry of our program is over here. The main entry of our program is over here, and there is a structure called cboard EEPROM. So the cboard EEPROM, we have defined it over here. So that's type def struct c underscore cboard EEPROM, and we have a character. So this is according to our wish. You can go and create it. So I'm having one character array called module ID, serial number, and the data, and that is type def to cboard EEPROM. So it is an structure. So in the main program, we are declaring two variables, board EEPROM and board. So in the board EEPROM, we are copying that module ID, and then we are copying that serial ID, and we are copying the data. Okay, so that is what is happening in these three lines. Then we are calling write board EEPROM, and we are passing this pointer argument, that is the address of this board EEPROM thing is we are passing it to as an argument to this write board EEPROM. In the write board EEPROM, that address has been passed, and then we are trying to open the EEPROM file board. So the EEPROM file board is nothing but our sys class. This is what the EEPROM file board, this is what the class. So this we are going to open. So once it open, it gives the file descriptor in the write only mode. Once this has been opened, we are writing the what are the contents in the board EEPROM of size size of C board EEPROM. That is what we are writing into that file descriptor. Okay, so if the write bytes is less than the C EEPROM, and suppose if the write bytes is of negative value, it is an error, nothing has been written. But if it is less than this size of this C board EEPROM, that structure means the content what we have given is more than the size of the EEPROM. So that's why we are giving that partially it has been written into the EEPROM. Okay, so then we are closing that FD. So once the write system call is called, now we are using the another the C board EEPROM structure variable, and we are copying the making that everything it as 0 cross 0 0. So we are making everything as 0 0, and we are trying to read. Next we are trying to read through this, passing this as an argument to the read EEPROM call function call. This read EEPROM function call, it is taking that as an argument pointer, that is the address of that board, the structure, this structure, and then we are making that as 0. The size of the structure we are making it as everything we are making it 0, and we are opening again we are opening that EEPROM file through this path, the device file through this path in the read only mode. Then we are using a read system call. So whatever the things inside this board EEPROM, we are trying to read. We are trying to read and put it in the file descriptor, and we close it. So we are trying to read. So whatever the things in the file descriptor that has been already written in the EEPROM, that we are trying to put inside this board EEPROM. So that means that inside this board, all the contents will be read. So then we are trying to print. Then the next thing we are printing the board.module ID, board.serial number, and board.data. So this is what the code flow of this I2C interface of EEPROM read and write. Let us compile the code. So it's been compiled. Already the toolchain has been enabled in this terminal, and then I'm copying the executable files to the TFTP boot in order to copy into the rugged board. So in the rugged board, we are copying it and changing the permission, and we try to execute the program. So whatever the things we have written, so it is a module ID and it is serial number, and then the PyTech whatever thing it has been written, we are able to read it. Okay, thank you.